This video is for Mrs. Rose's AB Calculus class. It is the second in a video series on Extrema from Chapter 3, Section 1. Returning to our earlier vocabulary, x equals a is a critical number if a belongs to the domain and if the slope at a is 0 or the slope at a is undefined. The next two vocab words you already pretty much know. A maximum is the point on a curve f of x that has the highest y value, and a minimum is the point on a curve that has the lowest y value. Now we're going to add some calculus to those definitions. We can say that f of x has a relative maximum at x equals c if the derivative at c is 0 or is undefined, and the derivative f prime of x changes from positive to negative at that value. So if we look at this upside down quadratic, we know, because we have a horizontal tangent line, that the derivative at c is 0, but it's changing from a positive slope, where f prime of x is greater than 0, to a negative slope after c, where f prime of x is less than 0. So therefore, at this point, we have a relative maximum. Similarly, on the second graph, this point here is a relative maximum because we have f prime of c undefined, and the slope at that point is changing from positive to negative. We also have the definition f of x has a relative minimum at x equals c if the derivative or the slope at c is 0 or undefined, and f prime of x changes from negative to positive. So at c we have a relative minimum because we know that the derivative at that point is 0 and that slope is changing from a negative to a positive. Similarly, on the fourth graph, we know that this is a relative minimum. F prime of c is undefined, and the slope is changing from a negative to a positive. Okay. Note, just because the derivative at an x value equals 0 does not guarantee that you have a relative maximum or minimum. If you look at a cubic, right here the slope is going to be 0, and we can show that with the derivative. dy dx equals 3 times x minus 2 squared times 1, and when you set that equal to 0, that's really just going to be x minus 2 squared equals 0, or x minus 2 equals 0, so x equals 2. So we know that the slope is 0 when x is 2, but the slope is positive before that x value, and it's also positive after that x value. Here comes a fairly important theorem, the extreme value theorem. It says that, oh no, hold on. Okay, the extreme value theorem says that if f of x is continuous on a closed interval from a to b, then f of x has an absolute maximum and an absolute minimum on the interval. So basically, if you have a graph and it's on a closed interval, you're going to have an absolute maximum and an absolute minimum. Absolute max at the highest y value on the graph, and absolute minimum on the lowest y value on the graph. Okay. Relative extrema, relative maximum minimums, can only occur when the slope is 0 or undefined. And just a quick reminder that the derivative is undefined if f of x is discontinuous, has a sharp corner or cusp, or a vertical tangent line. Also, absolute extrema can occur if the derivative is 0, or if it's undefined, or at the endpoints on a closed interval. So on this graph, we have an absolute minimum when the slope is 0, because it's the minimum point on the curve, but we have an absolute maximum at the endpoint, because that's where the highest point on the curve is. Okay, so here we're going to go through and label absolute and relative maximums and minimums. Right here, we have an absolute maximum because it's the highest point on the curve. And here we have a relative, but it's also an absolute, so I'm going to erase that relative. We have relative and absolute minimum. Okay. This graph, we have a relative maximum here, but we can't call it an absolute maximum because this graph goes up forever. So the highest y value would be infinity. But that's not an absolute number, so we can't call it an absolute max. Similarly, we have a relative minimum at this point, but we don't have an absolute minimum because the curve is going down to infinity forever. On our third graph, we're going to have two relative minimums here and here, and we're going to have two relative maximums at the top parts of our graphs, our top turning points. We're not going to have an absolute maximum because this graph goes on forever, but because the right end of the graph has an endpoint, we have an absolute minimum at the lowest possible y value. On our fourth and final graph, we have an relative minimum at that cusp, we have a relative maximum at that hump, and we have an absolute maximum at the end point. There's no, oh, just kidding. This is supposed to be an absolute maximum. Minimum, absolute minimum. This function has a horizontal asymptote, so it's going to get closer and closer to 0. So this point that actually touches 0 is the absolute minimum. Okay, please pause the video here if you'd like to copy down these guidelines for finding absolute extrema on a closed interval. Alright, let's look at an example of finding absolute extrema on the interval of the function f of x equals 3x to the fourth minus 4x cubed on the interval from -2. The first thing we need to do is find critical numbers. So we're going to take the derivative and set that equal to 0. Now solve for x. We're going to have two critical values from our derivative. Then what we need to do is evaluate, this was step 1 on our guidelines. The second step is going to be evaluate all critical values and endpoints in the original f of x. So I'm going to plug in 0 into my original. So 3 times 0 would be 0, minus 4 times 0 is 0, and that's going to be 0. And then I'm going to try the other critical value. Should be 3 minus 4 to be -1. And then we're going to plug in the two endpoints. -1, so 3 minus -4 is 7. And then plug in the other endpoint. And I'm going to get, let's see, 64 minus 32. Nope, 48. Which is 16. So then what you need to do is, oh, I guess this is step 2 and 3. Then what you need to do is decide which has the highest y value and which point has the lowest y value. And then we need to make a concluding statement. F of x has an absolute maximum at x equals, oh, not x, I need a point, excuse me, at 2, 16, and f of x has an absolute minimum at 1, negative 1. Okay. That concludes our example video of finding extrema on an interval. Good luck with your homework. Come to Chem Morning if you have any questions.